Okay. Today, I want to talk about section 2.4. This is no, I can change a little bit. Sorry, not this one. Just wait here. Yeah, this one. Okay. Could you see section 2.2, the derivative as a function, on your screen? Could you see? So if you see, this is section 2.2. Please write yes on the chatting board. Okay, good. Today, I want to talk about section 2.2, the derivative as a function. Today, here, let me see, comment. Yep, that's good. Okay. So first one, I'm gonna give it the outlines. So I'm gonna talk about definition of derivative of f, the higher derivatives, geometric interpretation of f prime, the differentiability. I'm going to talk about 4 kind of things today. The first one, definition of the derivative of f and higher derivatives. So we just only to remind section 2.1, the derivative of f at a. This is the same to limit f of a plus h minus f of a over h as h approaches 0. So we can use this notation, f prime of a, replace a by x. So we have this result. So what does it mean? Just only replace a by x. This is x, this is x, this is x, we have this one. So this is f prime of x. So we use another notation, dy of dx. So we call the derivative of f, or the first derivative of f. We call like so. Another one, limit f prime of x plus h minus f prime of x over h. We use the f double prime of x. We use this notation, d square of y over dx square. So we call the second derivative of f. The next one is the limit of second derivative of f of x plus h minus second derivative of f at x over h. This is like f triple prime of x. So we use another notation, d cube y over dx cube. So we call the third derivative of f. Was it like nth derivative? So we can use this notation. So what's that? The limit of what's this notation? This notation is n minus first derivative of f at x plus h minus, same. N minus first derivative of f at x over h. So this is like nth derivative of f of x. So this is d to n y over dx to n. So we call the nth derivative of f. So we can use this kind of same notation. So what's that? So this one is exactly same to the third derivative. You can use this notation. Third derivative, so like this one. This one, so we use second derivative. So like this. This one is like use notation first derivative. So one more. What is the zeroth derivative? The zeroth derivative of x is, so we use this one, exactly same to just f of x. This is like a zeroth derivative. We use this notation, so like this. The next one, the geometric interpretation of f prime. So what's like a geometric interpretation? F prime of x is the slope of the tangent line to the graph of f at x and f of x. This is geometric interpretation of f prime. So here, so we have one graph y equals f of x is given. I can draw the graph of y equals f of x. Graph is like this. This one. This is y equals f of x is given. I want to draw the graph f prime of x. F prime of x. So here I can draw the graph of f prime of x. Here I draw the graph, the f prime of x. What's like f prime of x? We can use this definition. F prime of x is the slope of the tangent line. I can choose this minimum value here. I can draw tangent line. This is horizontal tangent line. What's the slope? What's the slope? The linear slope of this tangent line. What's the slope? Is 1, 0, 0. Yes, slope is 0. The slope is 0. So you just only plot f prime of x. F prime of x is 0. Here, 0. Same. Slope is 0. The slope is 0. So this point here, so we have 0. Same. At this point, we have horizontal tangent line. Slope is 0. So slope tangent line is 0. You have to plot like this. The next, you can choose this point. So what happens? This is tangent line. This tangent line is, slope is a negative number. This slope of tangent line is, in this case, like -1. You can plot -1 here. You can plot here. Y value is -1. So like this. You choose this point. You can draw tangent line. This tangent line, the slope is like -1 over 2. Here, slope is -1 over 2. And here, slope is -1. The similar, you choose this point, you can draw tangent line, slope is 1 over 2. The slope is 1 over 2, you plot the here. This point, draw tangent line, the slope is 1. So we have 1. This point, 0 again, the keep going. You choose this point, slope is -1 over 2. So here, slope is -1 over 2. So here, you choose this point, slope is like -2. Draw here, slope is -2. This is -2. This point, slope is like -1. Here, the -1. This point slope is +1, right? This is slope is like +1. So we have, and this point. You can connect this whole point. So what happens? Graph is, this is, this is not a line like a curve. So we have the like this. This is f prime of x. This is a whole idea for sketching the graph of f prime. F prime is not inverse, so not inverse. This is not inverse. F prime of x is exactly the slope of the tangent line. This is the idea. It's good. This is not inverse function. Yep. So the next one is right. This is blue one is f of x. You can use my idea from the previous example. We can draw f prime of x is like a red one, right? The slope is 0. This point, the slope is 0. You plug, slope is 0. Here, slope is 0. Here, slope is like 3 over 2. You plug here. X value, Y value is 3 over 2. Here, 3 over 2. You have to plug and connect. So we have this kind of reference. Okay, next one. F of x equals x cubed negative x. Find f prime of x and second derivative and the third derivative and the first derivative. This is the idea. So here, f prime of x is definition, limit of x plus h minus f of x over h. So you can solve next one. H value approaches 0. You plug x plus h into here. So we have x plus h cubed minus x plus h minus f of x. F of x is this whole thing, x cubed minus x. X cubed minus x over h. So next, to expand. How can expand x plus h cubed? So do you know what is expanded form of x plus h cubed? Do you know that? What is x plus h cubed? Do you know? So do you know form? Perfect cube. Yeah, so how can you expand? So I'm gonna use FOIL rule several times. You're right. Christine's right. Yeah, thanks. X plus h, x plus h, x plus h, and keep going. First one, here x times x is x squared. X times h plus here, not this one. H times x is plus 2xh plus h times h is h squared times x plus h, and keep going. X times x squared is x cubed. X times 2xh is plus 2x squared h plus h times h squared is x h squared. The next one is h. H times x squared is x squared h. H times 2xh is plus 2xh squared plus h squared times h is h cubed. And here, x cubed plus 2x squared h plus x squared h is 3x squared h. xh squared plus 2xh squared is plus 3h squared. Last one, h cubed. So we have this form. So this first part is x cubed plus 3x squared h plus 3xh squared plus h cubed. You can distribute minus 1. So we have negative x, negative h. You can distribute minus 1 again. The negative x cubed plus x over h. So what happens? X cubed is cancelled. X is cancelled. So this is same to limit. H approaches 0. The remaining part is 3x squared h plus 3xh squared plus h cubed negative h over h. The next, the h is common factor. You factor out h. You factor out h. Keep limit h approaches 0. You factor out h. The first one, 3x squared. The second one, factor out h plus 3xh. Third one, h cubed, factor out h plus h squared. Last one, minus h, the factor out h negative 1 over h. H is crossed out. So we have limit. H approaches 0. We have 3x squared plus 3xh plus h squared minus 1. The next, you plug h equal to 0 into here. 3x times 0 is 0. 0 squared is 0. The remaining term is 3x squared minus 1. This one is exactly f prime of x. This is the whole idea for solving f prime of x. Does it make sense? So we have like this. This one. So we have it. So here, what is relation between f of x, f prime of x? I can compare. I can draw the graph, this one. This blue one is f of x is this blue one. The f prime of x is the 3x squared minus 1 is this red one. We can compare. Here, slope is 0, exactly this point. So what's it like slope? Slope is minus 1. Slope is minus 1 at 0. Yes, slope is minus 1. Here, slope is 0 at this point, going to here. So this point, slope is positive 1. We have here. This slope is like 2 or 3, like this. The key point. This is like a relation between f and f prime. The exactly same to previous example. The next, second derivative. How can you find second derivative? You can use definition. Limit f prime of x plus h minus f prime of x over h. So what's that? F prime of x is, from the previous page, 3x squared minus 1. So how can you solve? This is a limit h approaches 0, same. You plug x plus h into x for f prime of x. 3 times x plus h square minus 1. This is exactly f prime of x plus h minus f prime of x minus f prime of x is 3x squared minus 1 over h. So keep going. Limit h approaches 0. So what's that? 3 times what is x plus h squared? So we can calculate here. X plus h squared is x plus h times x plus h. You can use FOIL rule. X times x is x squared. X times h plus h times x is plus 2xh. H times h is h squared. So we have it. So we have x squared plus 2xh plus h squared minus 1. Remaining things distribute negative 1, negative 3x squared plus 1 over h. What happens? 1 is cancelled. The next distribute 3. 3x squared. Distribute 3 plus 6xh. Distribute 3. 3 times h squared is plus 3h squared negative 3x squared over h. The 3x squared is cancelled. This is a limit. H approaches 0. The remaining thing is 6xh, yeah, plus 3h squared over h. The h is common factor. The factor of h, the h times 6x plus 3h over h. H is crossed out. Limit h approaches 0. 6x plus 3h. The last one. You plug h into here, h equal to 0. 3 times 0 is 0. The remaining thing is 6x. This is second derivative. This is the whole idea. The third derivative, we can use definition. Limit of second derivative of f of x plus h minus second derivative of f at x over h. So how can you do that? This is a limit. H approaches 0. You plug x plus h into here, second derivative, this one, the 6x plus h minus the second derivative of fx is 6x over h. So limit h approaches 0, distribute 6. 6x plus 6h negative 6x over h. 6x is cancelled. We have limit h approaches 0, 6h over h. H is crossed out. We have limit 6 as h approaches 0. What's the limit of 6? What's the limit of 6 as h approaches 0? All right? Yes, thank you. The limit of 6 is constant 6. This is third derivative. So like this. Last one. The first derivative is limit of third derivative of x plus h minus the third derivative of f of x over h. So you plug x plus h into here. What is third derivative? What's that? What's the third derivative of x plus h? Answer is 6. Because here, yep, the third derivative of x is, we have it, only 6. You plug x plus h into here, function doesn't change. Minus third derivative is 6 over h, limit h approaches 0, 0 over h. The 0 over h is 0. Limit of 0 is 0. That's it. This is the answer. So like this. The next tip. So we can try to solve the more problem. F of x equals the square root of 2x minus 5. Find f prime second derivative and domains of f prime second derivative. First one, domain of f. What's the domain of f? The f of x is given here. What's the domain of f? Do you know domain of f? So could you write your answer of domain of f? The real numbers all non-negative. Is it right? So, does it make sense? No? Here. Was it like a domain of f? Inside one. 2x minus 5 is greater than or equal to 0, well-defined. The square root of a negative number is undefined. So domain is inside one, is greater than or equal to 0. This is domain. You just only add 5 to the both sides. So 5 is cancelled. So we have 2x is greater than or equal to 5 divided by 2. So we have x is greater than or equal to 5 over 2. This is domain. I can use the like interval rotation. This is what? Include 5 over 2 till infinity. This is domain of f. This is idea. Like this. The next is f prime of x. I want to use definition. Limit of f of x plus h minus f of x over h as h approaches 0. So what's that? This equals limit h approaches 0. You plug x plus h into here, only x. So we have square root of 2 times x plus h minus 5. The f of x is, this is the whole thing, minus square root of 2x minus 5 over h, like this, right? So we have it. The next step, how can you solve this limit problem? How can you solve? You can multiply top one and bottom by, what's that? Top one and bottom by conjugate of top one. What's the conjugate? You can keep square root of 2 times x plus h, yes, change only plus. Keep negative here, keep negative 5. Only change this negative sign. Plus root 2x minus 5, same. Square root of 2 times x plus h minus 5 plus root 2x minus 5. This is like step 1. So like this. The next here, you can just simplify. How can you simplify? Do you know this rule? A minus b times a plus b. What's that? Do you know what is a minus b times a plus b? So what is the answer? A squared plus b squared. Is it right? Yes, a squared minus b squared. So we have here a squared minus p squared. So this is limit. H approaches 0. This whole thing is a. A. This is a. A squared. Exactly. Square root of 2 times x plus h minus 5 squared. And minus. What's b? Root 2x minus 5 is b. b squared. Root 2x minus 5 squared over. Don't distribute bottom one. Keep. The root 2 times x plus h minus 5 plus root 2x minus 5. You can keep the square root and square is gone. Square root to square is gone. So we have limit. H approaches 0. Only 2x plus h minus 5 minus. You have to use parentheses. Only 2x minus 5. You can use parentheses here. Over remaining things. H times root 2x plus h minus 5 plus root 2x minus 5. Can keep. The next simplify. Limit h approaches 0. Distribute 2. So we have 2x plus 2h minus 5. Distribute negative 1. Negative 2x plus 5 over, I don't write exactly. Same denominator in here. Same denominator equals. Cancelled. Limit. H approaches 0. 2h over. Bottom one has h times square root of 2 times x plus h minus 5 plus root 2x minus 5. What happens? H is crossed out. Crossed out. So I can show this part is here. So like this. H crossed out. So we have it. The next, you plug h equal to 0 into here. This is 0. What's the remaining things? 2 over square root of x plus 0 is x. X times 2 is 2x minus 5. Bottom one more. Root square root of 2x minus 5. So this is same to 2 over exactly the 2 times square root of 2x minus 5. 2 is crossed out. Answer is 1 over square root of 2x minus 5. So that's it. What's the domain of f prime? What's the domain of f prime? What's the domain of f prime? What's f prime of x? F prime of x is this function. F prime of x is 1 over square root of 2x minus 5. How can you find domain of f prime? The 1 over square root of 2x minus 5 equal to 0. Was it like a domain? The next one. Bottom one is non-zero. bottom one equal to 0, undefined. This is not in the domain. One more. The 2x minus 5 is in square root. 2x minus 5 is greater than y equal to 0 and non-zero. 2x minus 5 is non-zero. You can combine these two inequality. So exactly 2x minus 5 is just positive one. You add 5 to both sides. 5 is cancelled. 2x is greater than 5. Divided by 2. X is greater than 5 over 2. So what's like the next? You can change interval, open interval, 5 to infinity. This is like a domain of f prime. Let me see. In this problem, domain of f is half closed interval. Domain of f prime is open interval. Is right. You have to exclude 5 over 2. Like this. This is the idea. So like this. The next, the second derivative, I want to skip. So you can study by yourself by using my lecture note. Idea is very similar to the f prime. I want to skip. You can study by yourself. This one. So like this. Study by yourself. The next, definition of differentiability. The definition of differentiability. So what's it like the definition of differentiability? This is the definition. Function f is differentiable at a. What's that? If f prime of a exists. This is differentiable. The function f is differentiable on open interval a, b, or minus infinity, or all real number minus infinity, if it is differentiable at every number in the interval. This is differentiable on open interval. This is the definition. Here, you can check function at where is the function f of x equals absolute value of x differentiable. So what's that? What's that? Positive numbers? How about what about negative numbers? What's the negative numbers? No. No. The non-negative numbers? So let me see. I want to use geometric method for solving this problem. Yeah, here, all function f is differentiable at a if f prime of a exists. What is like geometric meaning of f prime of a? What is geometric meaning of f prime of a? Remember, what is geometric meaning of f prime of a? Not 0. The tangent line has slope 0, horizontal tangent line, that we call horizontal. So f prime of a exists was exact meaning. So we have a unique tangent line at a. It's like exact meaning is there is exactly one tangent line at a. This is like geometric meaning of differentiability. The one example, the graph is like this. You can see this point. This is differentiable or not, and this point here. You can draw tangent line. Yes, we have only one tangent line. Yes, differentiable. This is the idea. Here, do you know graph of f of x equals absolute value of x? You can sketch the graph. Yeah, like V, you're right. Thank you. Here, graph is like this and like this, like V. The V. You can choose positive number X here. So we have it. Was it like tangent line? You can draw a tangent line exactly same to this line. We have one tangent line. It's good. Here, was it tangent line? Exactly one tangent line. Exactly same to this line at this point. So what does it mean? So f of x is differentiable at positive number, negative number, it doesn't matter. How about zero? What's that? This is like a corner. Differentiable or not at zero. So what do you think? What is zero? Differentiable? Zero? Here, I want to draw tangent line. What is tangent line? This one is tangent line. This one is tangent line. This one is tangent line. This one. So what does it mean? We don't have exactly one tangent line. Here, we have like a corner. So we cannot draw unique tangent line. We have infinitely many possibilities. What does it mean? This is not differentiable. Not differentiable. At zero. So not differentiable at zero. We don't have a unique tangent line. But you choose point is here, this point. Tangent line is this one. What's the slope? What's the slope of this line? The slope is, yes, -1. You can choose this point. What's the slope? Yes, slope is +1. So I can draw f prime of x. What's graph? F prime of x is, this is graph. Negative number, slope is -1, except 0. This is -1. X is positive, slope is 1. What happens at 0? Not differentiable, like 오픈다. This is a graph of f prime of x. So what does it mean? Function f is differentiable on. So here, the function f, x equals absolute value of x is differentiable. Differentiable on all real numbers except 0. Like so, except 0. This is the idea. So we have one good result from this function. We have corner. What's that? Not differentiable at corner. Not differentiable at corner. So we have, you can just skip. This is like algebraic calculation. So if you are very curious, you can read it by yourself. So I'll explain this one. So using geometric things, very useful. Very useful. So like this. Remark. So if the graph of f has a corner or cusp in it, then the graph of f has no tangent line at this point. What does it mean? F is not differentiable there. Not differentiable. This is one good result of non-differentiability. Here, second case of non-differentiability is from the relation of continuity and differentiability. We have one important theorem. If function f is differentiable at a, then f is continuous at a. This is theorem. So do you know what is the definition of function f is continuous? Do you know definition? Function f is continuous? The definition is like this one. Definition of continuity is limit f of x as x value approaches a is exactly same to f of a. This is definition of continuity. I want to prove. So we can use this assumption. Function f is differentiable at a. What does it mean? F prime of a, I want to use definition, limit, x approaches a, f of x minus f of a over x minus a exists. This is exact meaning. F prime of a exists. That's right. This is definition. So what does it mean? This limit value is finite number. This is like exact meaning. Exact meaning. But let me see. How can you prove f is continuity? I can follow this algebraic calculation here. F of x minus f of a is given. I can change this one to the like this one. So f of x minus f of a only divided by x minus a times x minus a. Is it possible? The x minus a is crossed out, exactly same. Exactly same. The next, take limit the both sides. Take limit the both sides. Take limit x value approaches a. Take limit x value approaches a. So what's that? This is like a product of two functions. You can distribute limit to the first and second one. So we have limit x value approaches a, the f of x minus f of a over x minus a times limit x approaches a, x minus a. You calculate the limit of f of x minus f of a over x minus a as x approaches a is here, f prime of a times what's the limit of x minus a? You can use direct substitution property. You plug a into x. So we have a minus a. So we have f prime of a times 0, exactly 0. What's the conclusion? We have this conclusion. Limit of f of x minus f of a is 0. We have this result. Limit f of x minus f of a as x value approaches a equal to 0. So we have it. The next thing, I want to prove continuity. The limit of f of x equals f of a. How can you prove? I can use this method here. Limit x value approaches a, f of x. I can use this algebraic skill. F of x is given. You just only subtract f of a and add f of a, exactly same, right? Because f of a is cancelled. The next grouping. Distribute limit to the first and second one. Limit x approaches a, f of x minus f of a plus limit x approaches a, f of a like this. So what's that? What is limit of f of x minus f of a? What's the answer? What's the limit f of x minus f of a as x approaches a? What is the answer? Do you know answer of this question? 0? Is it 0? Yes, we have previous result here, 0. We have previous result. This is 0 plus. What is limit of f of a? What's the limit of f of a as x approaches a? So f of a. The f of a. The one example is here. One example, limit x value approaches 5. 5 cube. What's that? 5 cube is constant. Limit of constant is constant. This is a very important thing. Here, what's f of a? This f of a is function value, exactly constant. Constant. Limit of constant is constant f of a. We have 0 plus f of a is f of a. What's the conclusion? Limit of f of x as x approaches a is f of a. I proved. Function f is continuous. That's it. This is a whole procedure for proving this theorem. So like this. The remark. The converse is true. The so far was like a theorem. The f is differentiable. Here, this is like a converse one. So if f is continuous at a, then f is differentiable at a. This is true or false? This is a remark. So was it like a theorem? Do you remember theorem? The theorem is if the f is differentiable, at a, then f is continuous. This is exactly previous theorem. Continuous at a. What's the converse one? So if f, this is like true, this is like a theorem, this is like a theorem, the true. The f is continuous at a, then f is differentiable at a. True or false? What do you think? What's true or false? This statement. So what do you think? This statement is true or false? Which one? So true or false? So what do you think? The function f is the first. You're right. The first. Yeah. Do you have an example? Do you have some example? The example is function f is continuous at a, but not differentiable at a. So do you know example? Zero. What does it mean, the zero? So example is like this. Yeah, absolute value thing. You're right. Good. So f of x is absolute value of x. The graph is this one. At corner, what's that? Well connected. Function f is continuous. Continuous at 0. But the function f is not differentiable. Oh, yeah, like a jump. You can draw it like your eye. You can draw f prime of x. F prime is here like this, here like a jump. Yeah, f prime is like a jump. Yes, not differentiable. You're right. The cause of jump from the f prime, So another one is like corner. The at corner, function f is continuous at corner, but not differentiable because we don't have unique tangent line. We don't have a unique tangent line. So I want to use the contraposition. This is like some logic. So this statement is true. So if function f is not differentiable, not continuous, sorry. The function f is not continuous at a, then function f is not differentiable. Not differentiable at a. This statement is always true by using contraposition, some logic. So we have it. So was it like a function f is not differentiable? This is like discontinuity. So do you remember we have three kinds of discontinuity? Do you remember? Was it like three kinds of discontinuity? So could you write the three kinds of discontinuity? So do you remember discontinuity, jump, infinite? We have one more. Jump discontinuity, infinite discontinuity, one more. Do you remember? The negative infinity is like infinity. So we have removable, is right? Do you remember? So we have three things. I can explain that later here. This is second one, like this. So was it like the three kinds of discontinuities? We have removable discontinuity. So we have jump discontinuity. We have infinite discontinuity. We have three discontinuities, infinite discontinuities. So I can check this kind of things. We have graphs like this. We have hole like this at A. What's that? This is removable discontinuity. Yep, removable discontinuity. So what's that? Function f is what? Not differentiable. So automatically function f is not differentiable. Not differentiable at A. This is idea. Similar. We have jump discontinuity. This is what? Jump discontinuity. Automatically function f is not differentiable at A. Similarly, so we have graph is going up. So like this. What's that? Infinite discontinuity at A. So this is infinite discontinuity. Infinite discontinuity. Automatically function f is not differentiable at A. This is second non-differentiability. What's that? Function f is discontinuous at A. What's the conclusion? F is not differentiable at A. So we have this kind of result. The third case of non-differentiability is from the vertical tangent line. F of x equals cube root of x. You can calculate f prime of x is 1 over 3 times cube root of x squared. So don't worry about this kind of result. So we learn this kind of derivative the next week. The Kasha will explain everything. So I want to use like later result. So what's that? Limit of f prime of x, x approaches 0. What happens? Infinity. The y here. Limit x value approaches 0. 1 over 3 times cube root of x squared. You plug 0 into here, f prime of x, what happens? 1 over 0 form. What is the possible answers? infinity or negative infinity. In this case, the 2 is like even power. This even power. Even power is always positive. 1 is positive. Answer is infinity. This is the whole idea. This is true? Yes. You can sketch the graph. It's very clear. You can draw f of x equals cube root of x. Graph is like this. This is f of x equals the cube root of x. So what happens? You can choose this point. This is like a tangent line. Choose this point. This is tangent line. So what happens? X value approaches 0. What happens to tangent line? Tangent line is exactly y-axis, like vertical tangent line. Same. You can choose this point. This is like tangent line. This point, this tangent line. So move to the 0. What happens? Slope is increasing, 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 going to positive infinity. Exactly vertical tangent line, so like this. So we have this result. F is not differentiable at A if the curve of F has a vertical tangent line when x equals A, that is, F is continuous at A. And limit of F, absolute value of F prime of X equal to infinity. This is called vertical tangent line. This is like idea. So summarize. There are 3 possibilities of non-differentiability at x equals j. What's that? First one, the graph of f has corner or cusp, so not differentiable. Second case, f is not continuous at a, x equals a, at x equals a. Removable discontinuity, jump discontinuity, and infinite discontinuity. In this case, not differentiable. Third one, the graph of f has vertical tangent line. Function f is not differentiable. We have 3 kind of things. I can give examples here. So, could you find non-differentiability things? The function f is not differentiable. So non-differentiable, not differentiable at point x. What is a point x? What's that? Jump at 0. Yeah, jump at 0. That's it. Jump at 0. That's it. Only 1 point. 0. So, do you have a corner? Could you get a corner? Yeah, -4 here. Yes. We have 0. Exactly. Jump discontinuity at 0. We have -4. We have corner. This is corner, not differentiable. Here at 0, what happens? Jump discontinuity. Jump discontinuity. So like this. We have 2 points, 0 and -4. So like this. Here, the function f is not differentiable. Function f is not differentiable at x. What is x value? -1. We don't have -1. The -1 is here. So let me see. This is like well connected, like this. Is 1? Is 1? 1, 5, 1. This is 1. What kind of result? Y. At 1, the y. Infinite discontinuity. At 5 here, 5. What kind of discontinuity? Not that discontinuity. So what is it like a region? Vertical tangent line? Yes. Here, infinite discontinuity. So we have this graph is going up. This is going up, going to infinity. So doesn't meet together. Infinite discontinuity. Oh. This is infinite discontinuity. This graph is somewhat not clear. The purpose is, yes, like vertical tangent line. So we have vertical tangent line at 5. So we have 1 and 5. You're right, it's good. Like this. Okay, so this is all for today's lecture. So do you have any question? So if you have any question, could you write your question on the chatting board? So I will answer your question. So if you don't have any question, you can leave this live session. Yeah. You're welcome. You're welcome. You're welcome. Good night.